Backyard Professor Math videos. We are approaching a time in algebra now to where we're approaching what I consider to be another one of the pillars of algebra. Fractions is one of those pillars, well, not only of algebra, but of all of mathematics. Fractions is one of those, and graphing equations with the Cartesian coordinate system is another one. And we begin to learn to graph on a number line, but the Cartesian coordinate system has two axes that we use to graph equations. Linear equations is what I'm going to bring us up to. All the calculus books that I'm looking in right now and studying say that a passing acquaintance with linear equations is not good enough. You have to know this material. So I'm going to really begin introducing you, and we're going to become familiar through practice of how to solve them. With the operations are always the same. My clock fell over. It's windy today. The operations are always the same. So it's irrelevant what size numbers we're dealing with. We learn how to solve the linear equations, and then later on we'll learn how to graph those equations. Graphing is one of the great genius breakthroughs in mathematics. It expanded our ability to solve word and world problems beyond anything before or since, I think. You're already familiar with linear equations, however. I've been doing them with you. So let's practice a few more. Let me show you what I'm talking about, and let's get familiar to the point to where they don't intimidate us at all. We just see them and we go, oh yeah, I thought algebra was supposed to be hard. One such equation is x plus 5 equals 7. A linear equation is an equation that has a variable in it. That's it. We don't know what this value of x is yet. That looks familiar, doesn't it? If you watch my earlier videos, you know I've already done these. What do? We isolate x by subtracting 5 here. 7 minus 5 is 2. So x equals 2. When you plug 2 back in there, 2 plus 5 is 7. It's that simple. That's how to solve that. If you have d minus 4 equals 11, we have to add 4 to both sides to isolate d. So when we do that, 11 plus 4 is 15, so that we know d is 15. When we put 15 here, 15 subtract 4 is indeed 11, so we know we got the right answer. It's that simple. This introduces us to the... Now I'm going to call linear equations more complicated, but that doesn't mean they're more difficult. And this is an important distinction. They are not more difficult, they're just more complicated. Meaning perhaps there's 2 or 3 extra steps to take to solve a linear equation. Plus b equals 5 halves. Now here we have fractions. Fractions are going to become our best friends in linear equations when we go to graph them. I promise. The fractions tell you how to graph your equation. You will love it. You will love to learn how to turn whole numbers into fractions to make it easier to solve the solutions. Truly, I'm truly serious. So here we have negative 2/3 plus b is 5 halves. Someone's added or subtracted negative 2/3 from this. How do we get rid of this? We add 2/3 to both sides, right? So these go away, and we're left with b equals 5 halves and 2/3. Fractions are easy. We're adding, so we have to have a common denominator. The common denominator of both 2 and 3 is 6. So we multiply both by, we get 2 to 6. I'll do it this way. By multiplying it by 3. What you do to the bottom, you do to the top. So this is going to be 15/6 plus, we get 3 to 6 by times it by 2, 2/3 times 2 over 2, and that equals 4/6, so that we have 15/6 and 4/6. 15/6 and 4/6 is simply 19/6. And that is the answer, 19/6. See, once you find the common denominator, you know we're adding and subtracting. We have to get the least common denominator. You know how to do that. It's irrelevant what the size fraction is. Then you get the common denominator and simply add the numerators and keep the common denominator, and you end up with your answer, 19/6. It's honest to goodness that simple. There's nothing more complex than that to any of this. What if we're given x plus 1/2 equals -3/2? Someone's added a half, so we know we have to subtract it. We subtract it from this side, and it cancels. So I'm not going to bother doing these steps too much. -1/2 and +1/2 cancel. So we subtract 1/2 here. We're in subtraction, but we have a common denominator. So -3 minus is a plus, negative. You turn it into add and do the opposite sign. So this is -4/2. 2 goes into -4, -2 times. There's your answer. So fractions are not that difficult to work with. If we have an equation that says 6x equals 54, boy, my marker's not. 6x equals 54. What do we do with that? Someone's multiplied 6 to the x. We want it alone. We divide by 6. Those 6's cancel. What we do to this side, we do to this side, and that simply 6 into 54 is simply 9. Right? It's that simple. X minus 7 equals 12. Someone subtracted 7, so we have to add 7. So x equals 19. We add 7 to both sides. I'm not going to do that step because that simply cancels it. So adding it here gives me 19, and my x is isolated, so I have 19. It's truly not any more complex than that. If we're given an equation y over 8 equals 6. Now here we have a fraction, but we don't know what the numerator is. But that doesn't need to freeze us up. We know it's been divided by 8. How do you undo division? Through multiplication. You multiply both sides by 8, which is 8 over 1. The 8's cancel out, leaving the y by itself. And 6 times 8 is 48. So y equals 48. And when you put 48 in here, 48 over 8, 8 goes into 48 6 times, which is what the original equation was asking us to do. So that's the way to do fractions that you don't have the numerator in. It's not that difficult, you guys. It's truly simple. All of this leads us up to getting used to linear equations. What if we have x over 6 equals 10? Again, we have a fraction. We don't know the numerator, but we don't need to worry about that. We know x has been divided by 6. Undo division through multiplying, so we know we're going to multiply 6 by 10. X equals 60. Multiplying by 6 on this side cancels the 6 and isolates the x. 10 times 6 is 60. It's that simple. Now, here's one equation where I say more complex, but not more difficult. Understand this. 9x, we know automatically that 9 has been multiplied to x, plus 5 equals 20. The reason this is a little bit more involved is because now we have 2 operations that we have to solve. We know how to do these operations. Again, we've been doing them with fractions. We've been doing them with negative numbers. We've been doing them with positive numbers. It doesn't matter what the numbers are. The operations are consistently the same. And this is the power of mathematics. We know 9 has been multiplied to x, and we know 5 has been added to x. To isolate x, undo those two operations. We subtract 5, which leaves us, what's 20 minus 5? 15. And then we divide by 9. And there's your answer. 15/9. Now you see it's an improper fraction. You can leave it like that, and that is appropriate. If you're asked to turn it into a mixed number, however, you have to divide 9 into 15, which is 1 and 6/9. And 6/9 reduces to 2/3. So the answer is 1 and 2/3. Or 15/9, either way. It's okay either way. Now, if you have a negative 7 plus, say, y equals 13. See, here's the thing. Algebra's not that complicated, is it? You can say to yourself, wow, I'm smart enough to do equations like this, because you are. Don't ever tell yourself it's you. Don't ever tell yourself, well, I'm not smart enough. That's false. You are smart enough. We just have to know the operations. And once we know the operations, bing, bada, boom, baby, plug and chug and solve the problem. This is simple. Someone has added a negative number to the y. So what we do is we subtract it. That's a negative 7. This is actually y minus 7, isn't it? You take the positive part of y and put it over here. You take the negative part of 7 and put it over here, and it's simply y minus 7 equals 13. Now you just add 7, and y equals 20. It is that nice, isn't it? Okay? Let's say we have f plus 5/6 equals negative 7/12. Someone's added a fraction. How do we get rid of it? It's added. We simply subtract it to isolate the f. Minus 5/6. Now we're subtracting fractions. So we know, add and subtract, we need the least common denominator, right? Well, 12 will go into 12 once, and 6 will go into 12 twice. So the only thing we have to do is get 6 to 12. How do you do that? You multiply by 2, right? Times 2 over 2. What you do to the bottom, you do to the top. 5 times 2 is 10, and then 6 times 2 is 12. So now we have negative 7/12 minus 10/12. And here we get great practice with positives and negatives. When we subtract, it's the same as adding the opposite, right? So we add the opposite. Now it's a negative 7 plus negative 10 is negative 17/12. It's that simple. That's your answer. Piece of cake, isn't it? You can see that's an improper fraction. I'm going to leave it at that. Unless you're told otherwise, that's perfectly legitimate to do. X plus 2/3 equals negative 5/6. Here again, someone's added a fraction to our... We always want to isolate the variable, so we subtract that fraction. Subtract 2/3. We're subtracting, so we need a common denominator. 6 will go into 6, and 3 will go into 6. So how do you get 3 to 6? You multiply it by 2 on the top and the bottom. That equals 4/6. So negative 5/6 here. Subtract 4/6. That's a plus negative. It's negative 9/6. This will reduce because you can take a 3 out of both of these, right? So this is going to be equal, you take 3 out of negative 9 and it's negative 3, and you take 3 out of 6 and it's 2. So your answer is negative 3/2. Bing, bada, boom. Truly. And this is preparing us, as we become familiar with fractions, This is preparing us to work extensively with linear equations, which I'm right on the top of. Within a video or two, I'm going to be doing some linear equations with you. These are perfect preparation because linear equations bring in the fractions like crazy. And we want to be familiar with fractions so that we don't get stumped, and they are easy. We want to become best friends with fractions because they help us graph. I know, I've said that before. Okay, here we have z, someone's added a negative 8. This is equivalent to z minus 1/8. Those two are the same thing, just so you understand. As long as you keep the positive sign and keep the negative sign with addition and subtraction, you can switch those around, but you have to keep the same sign. Negative 3/4. Well, someone subtracted, so we're going to add 1/8. We need a common denominator because we're adding 8 to the common denominator, so negative 3/4. Whoops. I'm thinking 8 and thinking 4 and writing 8. Times 2 over 2 is negative 6/8 plus 1/8. Now a negative 6 plus 1 is you're starting in negative territory to the left of 0 and you're going to the right 1. So this is going to be negative 5, right? Negative 6 plus positive 1 is negative 5. Keep the same denominator, negative 5/8. Bing, bada, boom. We know how to do the operation. We know the order. We understand the principles and laws so that we can do this. 5 1/6 plus x equals 7. Now here we have a mixed number with a variable. It's okay. You can subtract this 5 1/6 over here if you want and leave x isolated, which is what we're going to do. Minus 5 1/6 at this point. If we subtract it here, it just cancels, right? Or no. I'm wrong. Hold on. See, you got to watch yourself. Yeah. If we subtract it, it cancels the positive. So we're subtracting. So let's turn this into fractions. Remember, I told you, you're going to want to turn some things into fractions that'll make it easier to do. In linear equations, we'll do this a lot. It'll become one of your favorite techniques, I promise. 6 times 5 is 30, plus 1 is 31/6, right? 7 is simply 7 over 1. Any number is automatically a fraction with 7 over 1. So we have 7 over 1 minus 31/6. We're subtracting, so we need a common denominator. This will go into 6, so we need to multiply this by 6 times. 6 times 7 is going to be 42/6. Subtract 31/6 is 11/6. It's that easy. When you know the operations, when you understand how the operations work, they are so easy to solve any equation, whether it's fractions, negative numbers, big numbers, small numbers, it doesn't matter. A plus 1/3 equals negative 1/4. By now, this is becoming, quite frankly, simple schmimple. True, right? We know someone added a third, so we're going to take it away. No problem. Minus 1/3. We know we're subtracting, so we need a common denominator. A common denominator with 4 and 3 is 12. 4 times 3 is 12. You get 4, so you multiply both by, let's do it this way. Negative 1/4 times 3 over 3 is going to be negative 3/12. Negative 1/3 times 4 over 4 is going to get that to 12, and that's going to be 4/12, negative 4/12. So we have negative 3/12 minus 4/12. We add the opposite, and this is negative, so it's negative 3 and negative 4 is negative 7/12. Not bad, is it? It's just not as tough as you used to think it was. Let's go back to an old one like this. 5x equals 60. We're going to mix it up a little bit. We know someone's multiplied 5 by x. We simply divide by 5. That's how to cancel that and isolate x all by itself. If we divide by 5 here, we divide by 5 here. X equals 5 into 60 is 12. Piece of cake, baby. And then finally, here's one that I thought was worth looking at, and then we'll stop it here. Negative x equals 9. How would you solve something like that? You have a negative in front of a variable, and then a simple equals 9. You have to make the variable positive always. This is equivalent, remember when I told you, this is equivalent to have a negative 1 times x equals 9. Whenever you see a negative, it's always an implied negative 1. Well, how do you get rid of a multiplied negative 1 with x? You divide by negative 1, don't you? What you do to this side, you have to do to this side. You divide by negative 1. Negative 1 into 9, there's an odd number of negatives in the division, therefore it's going to be a negative number. Negative 1 goes into 9, negative 9 times. See, essentially all you're doing with negative x equals 9 is you're taking the negative and you're giving it to the 9. But I want you to understand how you got that negative over there. This is going to become seriously fun and useful with linear equations. We'll do this a ton, man. So, I've been talking at about 150 miles an hour for the last half hour or so. The next couple of videos, all we're going to do is increase the complexity of the equations. It's not going to make it more difficult. It's going to make it more. It's going to make it more complex. Let me show you real quick. Yeah, I've got just enough time. Let's say 3x plus 3 equals 20. Well, we've done several of them like this. There's two operations. You subtract 3, so that's going to be 17, and then you divide by 3, so that's 17 thirds, right? But with the equations we want to start working with, we're going to have 3x plus 3 minus 8 equals 20 minus 4. But you see, it's more complex, but it's not more difficult than that above one, right? What you have here is like terms. There's a number, there's a number, there's a number, there's a number. The 3x is the oddball out here, right? So combine your like terms first, and that'll help you begin solving the equation. This is basically 3x. What's positive 3 minus 8? Minus 5 equals, what's 20 minus 4? 16. And here you are. You're back to this kind of equation. You just had a couple extra steps is all. 3x minus 5. Someone took away 5 from this. We want to add the 5. That will eliminate that. Then we divide by 3. 16 plus 5 is 21. You divide by 3. 3 goes into 21 7 times. So you see, more complex, yes. More difficult? Not at all. And that's great news, isn't it? All right, thanks for watching my Backyard Professor Math videos. Remember, happy calculating, have a great life, and I'll see you in the next video. We're on a roll, baby. Woohoo!